All right. So today we're going to look at our next topic, possibly our last topic for our forensics class. Though there might be another section I add. We'll just kind of have to wait and see. But I would anticipate this probably will be the last one. But anyway, this section looking at a topic that I really enjoy and find quite fascinating, and that is, or those are the topics of firearms and ballistics. Now ballistics are going to pertain to any type of projectile that's been launched out of a firearm. So it kind of makes sense that the two kind of go hand in hand. But again, this is one of those topics that when you look at television shows or crime reporting shows or things along those lines, ballistics is oftentimes one of those that's going to be included in that. Um, for lots of reasons. It's not uncommon for ballistic evidence to be found, but it also makes for some sensational reporting. There have been a number of cases historically. One of the more I'm going to say recent, and it's over 20 years old now, but it was the Washington D.C. sniper case, where you had a gentleman driving around, you had another gentleman in the trunk of the vehicle, and they would set up in different locations, and they would unfortunately shoot people. Ended up with 10 people killed and three others injured, three other individuals injured as a result of their actions. But it's a really interesting story. If you have a few minutes, it would be worth kind of looking that up and reviewing kind of what took place. But just an interesting idea nonetheless. So this section, some different things that you'll need to be able to do by the time that we get to the end of this. Be able to identify and describe differences in the types of firearms, and then the cartridges that each of those firearms are responsible for firing. Similarities, differences, um, those types of things, being able to discern between different um, rates of fire and how those rates of fire are achieved, things along those lines. The parts that make up a cartridge, so the actual bullet that is loaded into a firearm and then fired, what allows that to take place, the twist as it relates to the barrel formation of firearms and what that does in terms of accuracy of that firearm, and kind of how that works just a little bit. Being able to use fired cartridges to determine if multiple cartridges or if subsequent cartridges were fired by the same weapon. That is an activity that we'll be doing in person if we have the opportunity to do this class in person, and if not, I believe I believe that I've got a couple different activities that you'll be able to do to still analyze that. So hopefully you'll get some practice there, and then obviously the restoration of serial numbers, and we're going to talk about it in the context of ballistics. This could have been put into trace evidence. This could have been put into tool marks. It could have fit into lots of different areas just due to the prevalence of serial number restoration. But I've included it in this section. Just kinds of this tends to fit pretty well. And then being able to calculate bullet trajectory and then use that to determine where a shot might have come from, to determine maybe a height of the shooter or whatever. So it'll be a little bit of math involved in this section as well. All right, so introduction for this. There are a number of things that you can use ballistic evidence to help solve as it pertains to forensics, in the event that you have some type of crime that took place or some type of action that may have occurred, and ballistic evidence is going to be very useful to that means. So some of the things that are going to be used in that, or can be used to determine that, if you have firearms that have been recovered from a crime scene, or firearms that are recovered, those can be compared to bullets that you may have recovered. They can be compared to cartridges that you may have come in contact with. You could even get fingerprints and things like that, DNA evidence from those firearms as well. We're not going to really talk about that per se a whole lot this section, but again, that ties in with some of what we've talked about previously. and it kind of excuse me, makes sense when we start tying everything all together. The spent cartridges themselves, whether you're talking about shotguns or rifles or handguns, as the case might be, all of those will have cartridges of some type, and those cartridges have forensic value associated with them. We'll talk about that as we kind of go through this section as well. If you have bullets, now I don't know why I have embedded in a murder victim. I should probably change that. But if you have any bullet fragments or large enough bullet pieces or bullets themselves that are in fact removed from a victim, sometimes those can be compared. Maybe you have bullets that have been fired. Maybe there's some type of drive-by activity, and you have bullets that were fired into a home. You can remove those from drywall or wood casings or whatever the case might be. You can get those out, and those are going to again form some of the evidence that can be used in a court of law. Again, there's lots of different ways that bullets could be recovered, but those are just a couple of them, right? So, as I mentioned previously, ballistic evidence is any evidence that is going to be associated with the uh, launching of a projectile from a firearm for one reason or another, even if it's not used in let's say like a murder or something like that. There have been cases where, like, people sometimes when they celebrate will fire firearms into the air. There have been cases where those projectiles have returned to the surface of the planet, and in doing so, have struck individuals. Um, and while it's not a deliberate act of harming someone, unfortunately, it still does fall into the category of murder. Or homicide, at least. Let's go with homicide, and so at that point in time, again, people have to be held accountable, right? And so that ballistic evidence becomes very important when those investigations begin. All right, so as we look, much like we've done with many of our other topics in our class, we're going to look at the history a little bit associated with gunpowder and firearms. Now, this isn't specifically in terms of our understanding from a forensic standpoint of ballistic information, but just in terms of firearms themselves. So it began with the Chinese greater than a thousand years ago with the discovery, the invention of a gunpowder. Um, During this time period, you had a number of individuals that were attempting to um, come up with some way of prolonging life and um, improving riches and things like that. Well, gunpowder was a byproduct of that. And obviously, since then, it's been used in a number of different ways, whether you're talking firework activities or projectiles or mining activities or any number of other potential uses. But that's been a very important one that has shaped a lot of different activities that's occurred on our planet throughout history, which is good and bad, I guess. Both you could argue pretty easily. Now, you'll notice that in the 14th century, people figured out how to direct the force associated with the explosion of that gunpowder, right? And basically, at this point in time, you have the creation of your first firearms. Now, whether they were handheld or whether they were more like a cannon that was mounted, I don't know. I don't know the answer to that. I would anticipate that many of them would have been very crude handheld devices at that particular point in time. But that's the beginning, obviously, of kind of where we are today. So the earliest firearms used wicks that would be lit, and then that wick would carry the flame to the gunpowder. The gunpowder could then be ignited, and the projectile then could be launched from that firearm. So the very early ones were really crude in terms of kind of how they worked, and very primitive in terms of their design. You wouldn't have had any type of trigger mechanism or anything like that. They would have been single shot firearms that relied on this wick to be able to ignite that gunpowder. All right, so any type of moisture in the air, any type of moisture falling from the sky would significantly impact the ability of these firearms to ignite and obviously then to move the projectile. Now, not long after that, 1600s is when you started to see really a lot of advancements in firearms, and obviously that continues still today. But in the 1600s, you had flintlock firearms. Now, what you see here, this is a percussive firearm. Yeah, that percussion cap. So, percussive firearm. So, imagine that this hammer here, instead of having this cup on it, if you will, would have had a piece of flint. You would have had a strike plate. So, when this hammer was cocked, and subsequently when the trigger was pulled, that hammer would fall. The flint would strike the plate, and was designed to direct sparks down into this breech plug, basically down into, you would have gunpowder in the barrel that had been packed down in here, and so that spark would travel down to that gunpowder. The gunpowder would be ignited, and then obviously the projectile would leave the barrel of the gun. Um, but again, moisture would be a big problem with that, because again, it could dampen the gunpowder. It could make it very difficult for the flint to strike and strike a spark that obviously could make its way down to where you wanted it to go. So while flintlocks were a big improvement over the wicked firearms prior to that, these percussive firearms then replaced your flintlocks. All right, so you'll notice again about 200 years later. So really, if you look at it, we're on about 200-year intervals, from the 1400s, 1600s, now the 1800s. But these percussion cap firearms were much more reliable. So there is a small piece of metal that sticks up. It's called the nipple, and there's a little metal cap that is fitted with some ignition powder that's fit over top of that. And it's kind of a snug fit, not tight, but snug so that it doesn't fall off. And the way it works, cock the hammer, pull the trigger, hammer falls, strikes that percussion cap. And because that percussion cap is over top of that nipple, that ignition source then goes straight down into the breech, igniting your gunpowder much, much more reliably. Moisture wasn't as big of an issue, because, as you can see here, you can put the hammer over top of that without it being firearmed, or without it being fired. So you could keep it dry, um, and still be able to fire this firearm in wetter conditions, not super wet, because again, gunpowder is notorious for absorbing moisture out of the atmosphere. If you've ever shot black powder rifles, there is a momentary delay between the ignition of your primer, and then the ignition of the powder itself. It's not long, um, but it is noticeable, and that is improved over the flintlock, and then obviously much improved over the wick. Now, as we talk about ballistics, again, remember, any projectile that's launched out of a firearm is going to be studied in this particular area of study. One of the things that we'll talk about a little bit later is the bullet path that is going to be observed by bullets as they travel. So the trajectory of a projectile, it's influenced by lots of different things. Um, the mass of the projectile is going to be a very big one. So really heavy bullets, you're going to have to adjust your barrel angle. So if it's heavy, if I still want that bullet to hit here, and I have a really heavy bullet, I'm going to have to adjust where I'm shooting that bullet. Okay, because otherwise, if I keep it here and it's a really heavy bullet, it's going to drop faster. Other things that can be done, you can adjust powder measures and all kinds of stuff, but those are discussions that we can have at another time. But all of those things are going to influence how a bullet's going to travel, and obviously then the accuracy of that firearm. Well, now as we look at firearms, firearms are lumped, if you will, into two categories. You have your long guns, which includes your rifles and shotguns, and then your handguns. Um, so long guns in ideally are designed to be held with two hands. One hand that holds it up and into your shoulder, and then a second hand that's going to be out on the fore end of that firearm, helping to steady it. Because again, many of these firearms are a little bit longer. Now, today, we have really chopped down, if you will, a lot of these firearms. So something historically that may have been a two-handed firearm, people may have modified it today to get it down to us to be able to hold it with a single hand, not held like you would a handgun per se, but much more closely resembling that of a handgun than a true long gun. But as I mentioned, your long guns are going to be your rifles and shotguns. Different. There are several differences between them, and we want to look at some of those kind of as we go through this. But your rifles are designed to fire a single projectile that's going to be a bullet. Okay, so a bullet is the structure or is the um, object that leaves the barrel of a firearm. Now, oftentimes, if you're familiar with shooting or even familiar with television shows that discuss it, um, the cartridges that are put into firearms, oftentimes people will refer to them as bullets. And I know when I'm talking at home to our family and getting ready to go shoot and stuff, we'll talk about bullets, and that's what I'm referring to. I'm referring to the entire cartridge. Well, in reality, the bullet is just the portion of the cartridge that leaves the end of the gun. And we'll talk more about that here in just a little bit. Shotguns, again, the second type of long gun, shotguns are a little different. Actually, shotguns are a lot different. Um, Shotguns have the ability to fire either a single bullet or a collection of what's referred to as shot. And shot are just these small, oftentimes lead, although today there are a number of companies that are making steel and copper uh, shot, but it's a small collection of these small pellets. And they can number from a few, three, four, eight pellets up to 100 or more. So again, depending upon the size of the shotgun and the amount of shot that you're trying to project out of the end of that firearm. Okay. Handguns are those firearms that can be fired with one hand. Again, depending upon the size of the individual firing them, the caliber of the firearm, you get the idea. There's lots of things that are going to feed into this. But handguns are designed to be fired with just that single hand. The first handguns were going to be the revolvers. Colt. Samuel Colt was a guy that did this first in 1835. That was a big deal um, in terms of what he was able to produce. Okay, and handguns you'll sometimes see referred to as pistols. They're oftentimes used interchangeably, but there is a difference. Your revolvers are going to have a cylinder that rotates, and so as the trigger is pulled and a bullet leaves the end of the barrel and the hammer is cocked to shoot the next round, that cylinder will rotate, thus being a revolver. Now, regardless of whether you're talking long guns or shotguns or handguns, you have the semi-automatic versus single shot and occasionally the automatic discussions. So we need to understand the difference between them. So when the hammer is cocked on a firearm, and then we pull the trigger, and the hammer falls and strikes the cartridge, a bullet is fired. If that hammer does not reset itself, it's referred to as a single shot. Okay. So every time that I want to shoot, I've got to cock the hammer, pull the trigger, the gun goes bang. Okay. A semi-automatic gun, regardless of whether it's rifle, shotgun, or handgun, when you pull the trigger, so initially you'll have to cock the gun, you'll have to cock the hammer or rack the slide or whatever the case might be, cycle the action if we're talking about a shotgun, whatever. A semi-automatic firearm, when you pull the trigger and the gun goes bang, that firearm will reload itself. So it will eject a spent cartridge. It will load the next cartridge. And so when you pull the trigger the next time, it will go bang again. All right. Um, so they are going to fire at a more rapid rate most of the time than your single shots. If you've ever seen any of the trick shooters, they can sometimes run single shot firearms really fast. They are quite impressive. Some of those individuals, guys and gals both, they are really really good and really neat to watch. And then finally, the automatic firearms, which again, for most of us, we don't have the opportunity to handle. There are a few gun ranges, even in the state of Ohio, that you can go to and you can rent some automatic firearms just to see what they're like. But an automatic firearm, when you squeeze that trigger, as long as you have the trigger held, it will fire a round until all of the cartridges in the firearm are used up, or until you experience a malfunction of some type, which oftentimes, or sometimes I should say, can occur. Okay. So single shots, you have to cock it, shoot it each time you want to fire. Semi-automatics, you'll pull the trigger. Every one time that you pull the trigger, you will get one fire, one round, one cartridge to be fired. And an automatic, as long as you hold the trigger, you will have rounds that will be fired as long as there are enough in that firearm. So this here is a shotgun. There are several ways that we can know that. One of the main ways is if you look at the barrel. This is a very large barrel, um, and this has a shotgun design. Fire rifles won't look like this, and obviously it doesn't look like a handgun at all. So depending upon the style of shotgun or the round that you're shooting, it can have a single projectile that you might find here. This is another version of a slug. Both of these are going to be, or all three of these are going to be referred to as slugs because they're single projectiles that will leave that barrel. Uh, this is going to be buckshot. These two large lead spheres here, these are buckshot. And then these are going to be shot as well. I don't know what size this is. This is pretty good size shot as well. It may fall under the category of buckshot as well, just a smaller buckshot. Excuse me. But you can get down to shot that is going to be really, really small, about a sixteenth of an inch or less. So you can fit several hundred of those into what's referred to as the wad. So there's a little cup that sits in this part of the cartridge, the shotgun shell, and it's full of the shot. So as it's pushed out of the shell, that wad will keep it together, allowing it to exit the barrel of the firearm, improving its accuracy. Okay, so an important idea. One thing that I'd like to point out while we're out on this topic right now, you'll notice these striations on these two slugs. Keep that in mind when we talk about rifling here in just a little bit. Okay. All right. So speaking of rifling, firearms and rifling. So most shotguns. So I'm going to go back a slide here. Most shotguns, if you were to look down the barrel of this shotgun. And again, you don't do that with a loaded firearm. These guns are designed to, if you take off this, there's a nut right here on the end of the gun. If you take this nut off of the fore end, you can actually remove the barrel. With the barrel removed from the firearm, there's no chance of anything occurring. But you could look down that barrel, especially if you look from the breech end towards um, the end of the barrel where the bullet will leave, or the projectile will leave, and you'll notice that the inside of a shotgun barrel most of the time is smooth. Okay, they're sometimes referred to as smooth bore firearms, because rarely do you find shotguns that have rifling. Rifling is more common in handguns and in rifles themselves, and rifling is designed to improve the accuracy of that firearm. Okay. Because what happens is you will impart a spin on the firearm or on the bullet as it leaves the barrel of the firearm. And so, with that spiral, that keeps that bullet traveling more accurately or more true to the target. Now, the important thing about rifle or handgun barrels is that as this rifling is made, it results in each barrel being unique. Uh, Two barrels made, even one right after the other, are going to have very slight differences between them. and that ends up being very important. Um, Another thing that's going to create differences in barrels is the use of that firearm. So firing projectiles from that barrel causes unique wear patterns to take place inside that barrel. And so, again, sometimes that can result in unique characteristics, which is going to be very important as we continue talking about this. Those unique characteristics become very important when you're trying to identify a very specific firearm. Okay. So on the inside of the barrels, on the inside of a rifled barrel, you have the lands. The lands are these areas, the raised areas on the inside of the barrel, and then you have the grooves. The grooves are the lowered areas on the inside of that barrel. Okay. And so, what you end up with as those lands and grooves are made, they are made in a twisting pattern. So you can see here, here's the twist that's being made. All right, that's an important idea. So this would be us looking down the barrel of the firearm, which again you don't do. That's just a firearm safety no-no. Um, but that gives you an idea of kind of what that would look like. That's why this is obviously a drawing and not a real firearm. Um, but you can use this then to determine whether it's a right twist. This would be a right twist. So that's determined by thinking about being at the back end of the firearm. All right. So this would all twist to the right as we looked at it from behind. Okay. Left twist would go the other way. Okay. So again, just to give you some perspective as to what we're kind of looking at. Now, in 1968, you have the Gun Control Act as a result of the assassination of Dr. Martin Luther King Jr. And the Kennedy brothers. The, uh, the legislation decided that there needed to be something done, and so they enacted the Gun Control Act of 1968. There were a number of provisions in it prohibiting transport and sales and possession of firearms by certain individuals, and among other things. But a couple of the very important parts that this then began to require is that every firearm that's manufactured in the United States, that they then include a serial number that is unique to each firearm. Very important, right? Again, trying to identify where those came from. Some other things that you would find as part of the Gun Control Act, they had to include the make of the firearm. So whether it was a shotgun or a rifle, you would include the caliber and things like that. You would include the model, and then the history of the firearm, not so much, right? But these serial numbers, all of these serial numbers could be used to determine all of this information about that particular firearm. So the serial number is very useful. So let's say, for example, you can tell, or maybe you can't tell, but this picture is a picture of a revolver. This is the cylinder. The trigger is right here. You can't see the rest of it. This is the trigger guard, and then the barrel would be up here. Let's say someone files off the serial number. Maybe they remove the barrel. All right, so that would be very difficult to identify any information about this particular firearm. However, if you can restore this number, which we'll talk about later, now all of a sudden we know the caliber, we know who makes it, we know where it was bought or where it was made, who bought it, when it was purchased. So it contains lots of information that would be very useful to investigators and law enforcement personnel. Now, when we talk about the rifling of a barrel, right, whether it's right hand, left hand, all that good stuff, the rifling, like I said, is important for imparting spin to improve accuracy. Now, there are different ways that this rifling ends up being made, but regardless, that then can also be important to help determine unique characteristics that will be produced on the projectiles as well. So conventional rifle barreling conventional barrel rifling, sorry, is going to have sharp corners and sharp edges. So you've got your lands and grooves, and each of these, because of the sharpness, as that bullet. So bullets have a snug fit. As that bullet is forced out this barrel, each of these parts are going to leave unique characteristics on the bullet on its way out of the barrel. There is another type of barrel rifling technique that's known as polygonal barrel rifling. And what you'll notice, this is the polygonal barrel rifling. You'll notice there's no sharp edges. Okay, they talk about it in terms of hills and valleys. So valley, 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 right? But can still have a twist associated with it, as you can see in this particular picture. This does a nice job. So this is a cut view of a barrel, and you can see the twist as it would make its way through this barrel. But notice, so this is looking what would be out the front of so the front of the firearm would be here. This would be the back of the barrel back here, but notice how these all spin to the right. All right, so this is a right hand um, and right hand twist firearm or right hand twist barrel that this particular barrel came off of. But you'll notice no sharp edges in terms of lands and grooves. Got your hill, got your valley for each of the different ones around that. Okay. There are still some firearm manufacturers that use this. There aren't a lot, but there are some, and this does help to improve accuracy a little bit, but also this smoothness of this barrel makes a much tighter fit between the bullet and the barrel. So that improves some of the features and characteristics of that bullet. All right, so as I mentioned, rifling described as twist. The greater the number of twists, regardless of whether it's right or left, it doesn't matter. And different manufacturers go right, different manufacturers go left, does not matter whatsoever. Excuse me, but the twists are going to increase accuracy because it's going to make the bullet spin faster over a given period of time. Okay, so a 1 in 8 twist is going to be accurate, but a 1 in 12 is going to be more accurate, and a 1 in 48 is going to be really, really accurate. Okay, which would be a lot. I mean, that's going to have a lot of twists, but that's going to improve accuracy because that bullet is going to be spinning very, 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 very quickly as it flies through the air. So you have less chance of that bullet wobbling or getting some funky yaw or something like that as it travels. Okay, so that's the barrel rifling part. Now, in terms of manufacturing the barrels, again, from a forensic standpoint, since we're tying this all back into that, um, as these barrels are made, they're going to have certain characteristics associated with them. So this is one type of barrel cutting tool. And what happens, so this ring is a little smaller than this ring is a little smaller than this ring. So they get a little bit larger. But what happens is this end is attached to some type of um, cylinder. And this whole thing, and this ends up being about the length of the barrel. This ends up being pulled through the barrel as the barrel twists at a very specific rate. So that imparts the twist. Now, notice this is going to cut a groove, right? Because it's going to be deep, and this is going to be the land, right? So lands and grooves, because this is referred to as a negative. It's the opposite of what it'll look like in the barrel. Um, but kind of interesting, I think. So the grooves are going to be cut by machine, oftentimes. Whether you go one groove by one groove, which is going to be really really slow. Like I said, this is going to be all of the grooves at one time, again by machine primarily. They can also take and form the barrel over top of a reverse pattern. Again, a different way of being able to do that. They can also use lasers or chemicals to end up with the correct rifling that they want as well. So there's lots of different ways that this rifling is achieved. But regardless, all of these have the potential to create characteristics that can be used to identify an individual firearm, right? So we have class evidence. If we find a 9 millimeter bullet that's been embedded in a piece of wood, that eliminates all other calibers, right? So we know it's a 9 millimeter. Well, there's lots and lots and lots of 9 millimeter firearms. So you want to be able to take and associate that 9 millimeter bullet to a single individual firearm. And so that's where all of these characteristics start to become very, very important. Now, as we talk about bullets and the cartridges, so like I said, this is the bullet, right? This is the part that's going to leave the projectile or leave the firearm. This becomes the projectile as it's fired. This entire thing, and primarily this, is going to be the cartridge. Now, in this case, these are all from rifles. And so this is oftentimes referred to as brass, the rifle brass, right? So you get an idea of some of the different calibers, 50 BMG, all the way down to a 22, right? Which is a very, very common round. 7.62 is going to be your like AK-47, things like that. 308, that's your AR-10s. 223s, that's like your AR-15s for or most platforms. Going to be comparable to the 5.56 military cartridge, but you get the idea anyhow. Um, so this cartridge, some of the different parts that you'll find within this cartridge, you're going to have the primer. Now we can't see it in this picture. There's some other ones that I'll talk about it, but the primer is in this part down here. It's actually in the center of this. If you were to take this and lay it over so that you were looking at the end, this is going to be round, obviously, and in the center of that is going to be the primer. That primer contains some powder that when the or the firing pin strikes that primer, it ignites the primer. Um, that primer then is going to be used to ignite the gunpowder. This part of your cartridge contains the gunpowder. And again, the amount of gunpowder is dictated by the way that that particular cartridge is built. So even the same cartridge could be loaded in different ways. So individuals that reload their own ammunition are going to load it differently than if you were to go to Cabela's and buy a box off of the shelf. They're going to be loaded slightly differently based on what each individual is going to want to do. You've got the bullet itself, the projectile that will then fire or be fired from that cartridge. So really, when you look at this, there's not a whole lot to them. All right, there's really not much to a cartridge at all in terms of what's going to be fired. As I mentioned, the casing that's going to hold everything together. All right, so in this case, we'd refer to that as brass or the casing that you end up with. Okay, so there are different types of cartridges that you can have, right? This is talking about a center fire, and what that simply means is that in the center of that casing of that cartridge, this is the primer. So the firing pin of the firearm will strike the primer. That primer powder ignites and then ignites the gunpowder that's in the rest of the cartridge. The pressure builds in this case, and the only way that pressure can be directed is on that bullet. All right, so this is the larger opening, so it forces that bullet out under pressure. The bullet then will leave the firearm and become a projectile. Okay. So bullet primer powder, the head stamp. So like H&K, 59 millimeter. These are all parts of the head stamp. This is who makes it, H&K. So Heckler and Koch. And then this is the caliber of firearm. 50, I don't know exactly what that could be. It could be maybe a batch. It could be any number of things that number would represent. So like this one here, Winchester Luger, 9 millimeter. All right, so Winchester is the brand, the manufacturer of this brass, and then it's a 9 millimeter Luger is the firearm uh, caliber that's going to be used for. Okay, this is still a center fire, so this is the primer. This is a primer that's been struck. And you'll notice the divot right here. That's the firing pin that struck this primer, ignited the powder, ignited the gunpowder, bullet left the casing. Okay. So head stamp on the cartridge identifies several things. One, it's going to identify the caliber. Every brass that you find, provided that it's not been too badly damaged or it's not been altered in some way, will always list the caliber of that particular firearm. It's going to indicate who the manufacturer of it is. Those oftentimes they're going to be abbreviations because Winchester would take up a lot of this, and it wouldn't leave them enough room to identify the caliber. You might find other unique identifying like symbols that would represent who the manufacturer is, things like that. Those are going to be the two main things though that you're going to see. So in terms of how the firearm works, we've talked about this a little bit, or I've talked about this a little bit already. So the trigger is pulled, um, the hammer or firing pin then strikes the primer. The primer powder then is going to ignite. Once that primer powder ignites, that then is passed on to the gunpowder, and the gunpowder at that point in time is going to ignite as well. Now, if you remember, um, at the beginning of this section, we talked about flintlocks and wick ignited and percussion cap ignited firearms, and the fact that they used black powder. So black powder is a different powder than what is used in most firearms today. Most firearms today are going to use smokeless powder. It does not absorb water as readily, so it's much more water resistant. Burns much more accurately, burns much more clean, so it's less damaging on the firearm, less corrosive on the metal, and it's a lot more reliable in terms of its detonation. So, a couple things there, but anyhow, so the gunpowder supply then is going to ignite. The pressure from the expanding gases of that gunpowder burning then is going to put pressure on the bullet. As that pressure gets high enough, the bullet is pushed out of the casing and into the barrel. Once it's into the barrel, now it's going to spin as a result of the rifling, as we've talked about already, and it will then exit the barrel. That's a normal um, pull of the trigger and ignition. Now, sometimes you'll end up with what are called squib, SQUIB, squib rounds. A squib round is going to occur when there is an error, oftentimes in this part of the um, firing process. Maybe there was not enough gunpowder put in, or maybe the gunpowder's been compromised in some way. But the pressure builds up and pushes the bullet out of the cartridge, but there's not enough pressure to force it out of the barrel, and so you end up with a blockage of the barrel, which we know creates a very dangerous situation, or can create a very dangerous situation for the person holding the firearm or firing the firearm. Okay, so again, this is normal stuff, but uh, just share a little bit with you that I know, I guess, right? So here you go. You got the trigger, so you got the hammer. There are what are referred to as single action firearms and a double action firearms. A double action firearm, when you pull this trigger, it will pull the hammer back and allow the hammer to fall. So it not only cocks the hammer, but releases the hammer at a certain point as well. That's a double action revolver. A single, excuse me, a single action revolver, you have to manually pull back the hammer and cock it, and then you'll have to pull, and then you pull the trigger to get the hammer to fall. But the hammer does not reset itself on a single action firearm. Okay, so again, kind of different there. But anyhow, pull the trigger, hammer or firing pin strikes the cartridge, pressure builds. So I guess I should back up a step. Striking the primer, primer ignites. Primer powder ignites gunpowder in cartridge case. Pressure builds in cartridge case, forces bullet into the barrel, following the rifling out the end of the barrel. Right, that's the normal stuff that should take place. Now, as we talk about cartridges and their calibers, the caliber is a measure of the diameter of the bullet in most settings, not in all, though. Okay. Typically, they're measured in hundredths or thousandths of an inch, depending upon the caliber of the bullet. Um, so, for example, like a 223 in the United States, we refer to them as 223s, but if you see them written, they are 0.223. All right, so they're 223 thousandths of an inch in diameter. Right, that's what that's measuring for that particular firearm, or for a 308. There we refer to them as a 308. They're written as 0.308. So 308 thousandths of an inch. right? In terms of their diameter. So that's in the United States. European, typically they're going to use metric. So, for example, in the European method, you'd have the 9 millimeter or a 10 millimeter or whatever the case might be, right? That's going to be a difference that you'll find there. So, 9 millimeter fires 9 millimeter bullets, so on and so forth. So, this is giving you a mixture of both European measures. So, here's a 9 millimeter here. This is a European measure as well, 762 by 39. This is another European measure here. These are all um, American measures, right? Because they're going to be measured in hundredths or thousandths of an inch. Okay. But again, very useful. Now, that's going to hold true for rifles and handguns. For shotguns, that is different. Shotguns, they're going to be measured in gauges. And so the common ones that you'd find in the United States today are 12, 20, 16 occasionally, and then 410. 12 gauge is going to be the largest, followed by 20, followed by 16, and then followed by 410. Um, but again, to give you perspective, and each of those are going to correspond to the certain size of the barrel and things like that. Okay. All right. So when you look at bullet cartridges, or I'm sorry, cartridges from a firearm, there is a fair amount of information that can be ascertained from those cartridges. So you've got to, in order for this to be able to work, though, if you're going to compare it, you have to have something to compare it to. So let's say we go to a crime scene. There are bullet casings found on the ground. Maybe there are lots. Maybe let's say there's 10 9 millimeter casings, and we pick them up. Maybe the head stamps are different. Maybe they're the same. It doesn't really matter. But we want to know: did both of those, or were both of those fired from the same firearm? And there's several pieces of information that we can look at to be able to determine whether or not that did or did not happen. But in addition to that, we want to be able to examine bullets that we may recover. Uh, if we want to examine those, one of the things that that forensic ballistic examiners will have available to them is a water tank, and it's a tank that I don't know exactly how big they are. Probably 4 feet, probably about 4 feet high and about 4.5 to 5 feet long, and they're filled with water. And what will happen is the individual, the examiner, will put the firearm down in this tube, pull the trigger, allow the firearm to discharge, and that bullet, when it strikes the water, slows down very, 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 very quickly. And so then they can recover the bullet itself from inside the tank, and it's not destroyed. It's in good shape. It's intact, so that they can compare the lands and grooves and other characteristics on that bullet with some that could have been recovered from the scene. The other thing that they can use is also a gel block, a ballistics gel block, and that will again allow them to be able to compare bullets recovered from a crime scene to bullets that are fired from that firearm. You can also use ballistics soap, which is very similar to ballistics gel. It's not the exact same, but it's very, very similar. Um, and you can use that to be able to determine what happens as that bullet strikes a soft tissue type material, right? To be able to determine what the effects of that firearm will be. Okay. Again, being able to look at the path to see whether or not it gets distorted as that bullet travels through different density material. All right, so as you look at this, again, we can see impressions that are cut into the bullet itself. Okay, so we can see where the lands, the parts that stood up in the barrel were. It's going to cut a deeper spot into the bullet itself. And the groove, remember the groove was a deep part, so on the bullet, it's going to look like a high part. But you can compare those to be able to determine, does this bullet match this bullet, or were the, I guess not that the bullets match, but do the characteristics of each of these bullets match one another, suggesting that they were fired from the same barrel, right? That's the important part really that you want to be able to look at. Now the cartridges themselves are also going to have useful information. One of the things that you can look at are these firing pin marks. Oftentimes, you'll find that different manufacturers or even just different firearms made by the same manufacturer, the way those firing pins have been made and worn over time, they're going to leave a different style impression on your bullets, which is kind of interesting, kind of unique. You can also see breech lock markings. That's these structures that you'll see here, these parts that you'll see here on the end of the cartridge. So this is the primer, um, and where that meets as that breech closes and puts that cartridge into the barrel itself. That's going to leave certain impressions in that cartridge, and that's what we're looking at here and here as well. Excuse me. And what you'll notice is that in both cases, they do in fact match up. On semi-automatic firearms, and even sometimes on single-shot firearms, depending upon how they're ejected, there will be marks from the extractor or the ejectors, and that's oftentimes going to be on the rim of that cartridge as it's pulled from that firearm. So again, there's lots of information that can be gotten from those particular uh, markings. So we have center fire on the left. It's hit by the firing pin in the middle of the near the middle of the primer. Okay. This is a rim fire cartridge. Rim fire cartridges, the only ones that I know of are 22s, but you'll notice that the firing pin strikes the outside of it. So these rounds are not reloadable, um, because the primer powder has been formed into the cartridge itself. This primer can be pushed out, and you can push a new primer in, reload it with the correct powder, reload it with the correct bullet, and it's ready to be fired another time. Um, but again, notice even the rim fires have head stamps. Okay, so this is Super X. I believe Super X is a Winchester brand, if I remember right. But we noticed Federal 40 S&W. All right, so it's a 40 caliber firearm, and this is a federal brand ammunition cartridge that was recovered. Okay. Now, as firearms are fired, and as that gunpowder forces that projectile out of the barrel, um, what follows that bullet out of the barrel is the gunpowder. Some of it's not burned entirely, but a lot of it is. Um, and so that ends up being referred to as the gunshot residue. Gunshot residue, depending upon the type of firearm and all kinds of other conditions, that gunshot residue can end up in lots of different places. And so one of the things that will be that investigators will look for in the event of a shooting, they will take samples from potential suspects to see whether or not any gunshot residue is detected on their person. So they'll check their hands, maybe the backs of their hands, maybe the palms, and maybe if they wore a long sleeve shirt or pants, they may even take samples from those locations to see whether any gunshot residue is present, because it can end up in lots of different places. So in close quarters shootings, gunshot residue could be deposited on the victim, depending upon the proximity of the firearm to the victim. That's not uncommon at all. Um, and so again, investigators can use that to determine how close or how far away someone may have been from a firearm when it was fired. So this is a revolver. As revolvers are fired, you have some gases that are going to leave. So there's a little bit of a gap between this cylinder and the barrel. Well, there's a bunch of gases that escape from that location, and a lot of them will come back onto the individual. But you'll notice the gases that are following this, the gases here, all of this is going to travel with that bullet, um, from that firearm. And so again, that can be used to help determine a lot of different things. Now, what we're looking at here, this is a powder, what's referred to as a powder burn on an individual. You can see all the small little dots. Those are caused as a result of the gases and powder striking the skin of that individual and causing the wound that we see. And different body parts will behave very differently, uh, depending upon how that bullet strikes their body. All right. Now, what we know generally, entrance wounds are going to be smaller than exit wounds, with very few exceptions. That's going to hold pretty true. Potentially in a wound, you may be able to find fibers from clothing or fibers from maybe someone put a pillow over somebody else's head and then pulled the trigger trying to muffle so the sound of the gun blast. You could end up with fibers embedded that way. I've seen several different case studies where that has occurred. It's kind of interesting when you see those. So if the bullet is fired when the muzzle is in contact with the skin, you're going to end up with those burns on the skin as a result, but the deposition of that powder on that skin as well. In the event that you have a gunshot occurring over top of a solid material below that, like bone, radial tearing is going to be pretty common. And what that simply means, I'm going to use this again. So imagine this is our bullet hole. What you're going to end up with is tearing from that site. Okay. So again, something to just kind of keep in mind. Uh, I'll let you click on this and kind of take your way through it, but kind of interesting when you look at that as well. Beyond 4 feet, that's generally the pretty well accepted value for powder to end up on the individual. If you're under 4 feet, chances are pretty good you're going to end up with some powder on the individual being deposited. If you're over 4 feet, probably not. It's going to be dissipated or gotten rid of before it reaches there. So, as a bullet encounters an individual, right, or an organism, you have the laceration, the cutting and crushing as that bullet comes in contact with that tissue, right? But because it is moving at such a high rate of speed, the cutting and crushing can be quite significant. Now, there are bullets that are traveling so fast that their damage is somewhat mitigated by their speed. Um, and so, if you're thinking about individuals that are hunting animals, they want to make sure that the bullets that they're going to use are going to be the correct size to impart as much damage as possible to get that clean, lethal kill shot with just a single shot. Right? You don't want it to go through really fast and not do any damage. That's not going to allow that animal to die in a very fast fashion. It's going to be a very painful and much longer type of event. Cavitation is caused as a result of the tissue itself because of the force of the projectile striking that particular um, tissue at a certain rate of speed. It's going to cause that tissue to kind of expand and contract. Well, as it expands, that's going to create a cavity associated with that particular round. Larger caliber rounds tend to create greater cavitation, and cavitation can be one of those things that is very difficult if you're talking about it from the standpoint of like healthcare uh, to be able to make repairs. That's very very difficult. Okay, um, but oftentimes your higher velocity rounds are going to create very large cavitation channels, but they will oftentimes return to their initial shape mostly. The shock wave as a result of the compression, right, in the air, they're going to cause compressive injuries to the tissue as well. Okay, so you can see here gunshot residue up close, gunshot residue from further away. Um, doesn't say the exact distance, just several feet for this one. This one was up close, but again, to give you perspective as to the amount of gunshot residue that potentially could be found in a setting. Okay, so in terms of gravity and trajectory, um, like we talked earlier, gravity starts pulling downward on that projectile as soon as it leaves the barrel of that firearm. So if you're trying to hit a target, let's say our target is up here, we would have to change the flight path of our projectile to be able to hit that, right? And so using sights on firearms, whether it's open sights or a scope or a laser, in any of those scenarios, we use that device or those devices to compensate for the forces of gravity to be able to get us back to where we want to be able to go. Okay, so looking at what we're able to get from this, and I put the wrong animation on here, but hopefully we can kind of talk our way through this. I know there's a lot on this slide, but I want to talk about how this information can be used. So being able to use the trajectory of a firearm, or more importantly, of the projectile to estimate where a shooter fired a shot from. Okay. So there's a couple things that you need to know. One, the bullet hole in this seat is 4 feet above ground height. Okay. That's important. Um, the measurement from the bullet hole to the window is 23.9 on an angle. The angle itself, um, do I have it on here? I don't think I have it on here, but anyhow, you would need to know the angle that this is at as well. And then we got 23.5, 23 and a half inches from here to here on a flat line um, plane, if that makes any sense. Hopefully that does, right? And so then you take that back a little bit more, and we can go from a building. So where they suspect that the shot came from is 60 feet away, which is 720 inches. Okay. So what we need to figure out is we need to figure out how far away was the shooter first, and then how high was that shooter off the ground, because that can help us to tell what floor of the building the individual might have been on. So here's how you do that. You take the distance to the window. Okay, distance to the window, which is 23.9 inches, and the distance above the horizon is 23.5 inches, or along. That shouldn't be above. That should say along. I'm sorry. I'll get that corrected. Distance along. Actually, let's do that now while I'm thinking about it. Here we go. So distance along the horizon. Okay, so that's 23.5. That's going to equal C, which is our hypotenuse, which is our distance to the shooter, over the distance to the building, which somebody has measured out as 60 feet, which is 720 inches. Now, the reason that we're using inches here, inches, so it only makes sense that we would want to use inches, because if you use different units, you're going to get some weird stuff. Okay, so when you do the math here, you find out that our hypotenuse is 732.3 inches. Okay. So then we use a Pythagorean theorem, a squared plus b squared equals c squared. We know that a squared is 720 inches. We don't know b squared. That's what we're trying to figure out. It's going to tell us how high that shooter was. And we just calculated c at 732.3. So we're going to square that. Right? So when you do the math here, you end up with this coming out at 133 inches, which ends up being 11.08. We're going to round that to 11. Okay. But here's what you have to remember. So that is the height that the injury occurred at. We also need to include the distance from the ground, right? And the bullet hole is 4 feet above the ground, plus that 11 feet gives us 15 feet off of the ground, which means that the shooter was on the second floor of that building when that shot was fired. Okay, so that's one way of being able to do this particular calculation. Okay, like I said, I set it up and went the wrong way. Okay, all right. So here's another example. Person's riding a bike, struck in the head by a bullet. Based on the apparent wound track and helmet damage, they estimate that the angle of elevation to be 24 degrees. Okay. The distance from where the bike rider was struck to the building that the bullet was fired from was 152 feet. Okay. So they've estimated this. They've measured this. Okay. Measured this. And the height of the injury from the ground was 6 feet. But we want to know, well, how high was the shooter, right? Because that's what we need to know. So based on this information, what is the distance from ground level to the window where the bullet was fired from? Because again, that's going to allow us to determine what floor of that building was the bullet fired from. So this one's a little bit different in that, excuse me, we know our angle. Okay. Um, we're not looking for this distance right now. We're just looking for this height. Okay. So for this one, we have the angle. On the previous one, we did not. So for this, we're going to take this equation, tangent. Our tangent is going to equal our opposite over our adjacent. Okay. So we know our angle of 24 degrees. Okay. So tangent of 24 degrees equals our opposite, which we don't know, right? That's what we're calculating, divided by 152. Okay. So when you figure that out, you do the math. Our question mark, our adjacent, nope, I'm sorry, our opposite measure is 67.7 feet. We would round that to 68. But remember, that's 68 feet from the horizon. Okay. That's not from ground level, that's from the horizon. So we would then have to add our 6 feet to that. So 68 feet, remember we rounded that to 68 plus 6 gives us a total of 74 feet from ground level to the window. All right, so that's going to be approximately 7 stories, give or take just a little bit up in terms of that measure. You'll get some practice with those. So again, if you have questions as you're working through those, excuse me, please make sure you let me know. All right, much like we've seen with several of our other units that we've looked at, uh, uh, ballistics is no different in that it is really becoming computerized. There's a lot of technology that's becoming involved in this, and it's a good thing. All right, so the National Integrated Ballistic Information Network, NIBIN, as you can see here, what they have begun to do is really standardize. Um, how a lot of this ballistic information gets entered. And in terms of being able to access information very quickly with regards to calibers or casing descriptions or whatever it might be, they're playing a really big role in making that very accessible. All right, so both for firearms and projectiles, and there are even fingerprints, if you will, certain characteristics that are readily identifiable. So, in the event that you have a bullet cartridge that does not match up to anything else, you can upload images of that to these databases and search to see whether or not there are any that are matches. Right. So again, using some algorithms and AI stuff to be able to identify that. Okay. But again, trying to create evidence standards, things that are very repeatable and reliable in terms of what science is able to show. So the Organization of Scientific Area Committees, OSAC, is going to play a big role in that. So on here, you'll notice in this picture, you've got firing pin marks, you've got the breech face marks. I would guess these are probably going to be dimples. We can't see; it's not zoomed in enough for us. And this right here is an ejector mark. Okay, so when this 9 millimeter cartridge was removed from the firearm as it cycled its next round, that ejector left a very distinctive mark here, and I would argue that even this down here is probably the other part of that, right? But regardless, very important to have those. So coordinates those standards to improve the reliability of forensic science evidence, including digital images, right, of the firearm and its subsequent fingerprints. Very important information as it relates to kind of standardizing the practice of forensic ballistics. All right, last little bit here looking at serial number restoration. Like I said, this could have been included in a number of other places, but being able to restore serial numbers is very important. This is something that can take place on tools. Most tools have a serial number on them, and if you have somebody that has taken someone else's tools, they will oftentimes file away or grind off serial numbers. But oftentimes they can be brought back, if you will, right? So serial numbers are going to be used for individualizing tools, whether it's a specific lot number or whatever it might be. They're used on cars in terms of VINs, firearms, like I said, tools, implants, all kinds of different stuff, right? Very important that these serial numbers exist. So different ways that people will try to get rid of them, grinding them, like using acids to etch them away, filing them away, all of those. So if we compare, right, serial number on the left to serial number on the right, these are the same serial numbers. This has been its when it's been filed away, ground off, whatever, and this is after it's been repaired. And while it's not perfect, while it's pretty impressive, right? In terms of what you're able to see here on the right versus what you can't see here on the left. Okay. And so again, this could be used then to trace it back to a specific individual or a store or whatever the case might be. So there's different ways of being able to make this visible again. And in the event that you're able to take this class in person, we will work on trying to perform a serial number restoration. Sometimes it works really, really well, sometimes not as well. But what happens is as that serial number is removed, the metals, the crystalline structure of those metals ends up being stressed. And so if you can undo that stress, sort of, then it makes those images revisible, if you will, or visible again. So again, kind of unique in terms of being able to do this. And there's lots of different ways that this can be done. One of the ways that we will use is actually using sandpaper to try to make it so that we can clean it up so that you can actually see it. There's electrostatic techniques, and there's a number of ways that this can be accomplished. But anyhow, one of the other techniques that can be used in forensic examinations of firearms in the event that somebody's tried to get rid of a serial number. All right. Well, I hope this unit was interesting to you. If you have any questions, make sure you please reach out to me. Otherwise, I will talk to you again soon.